story includes the latest earthquake that has devastated the Vancouver area. The 9.1 magnitude level earthquake that has struck Vancouver have left many people injured and homeless. This is the largest earthquake that has struck the region since the 1946 earthquake that hit Vancouver Island with a 7.3 magnitude. Other earthquakes can be recorded as far back as 1918, again on Vancouver Island with a 7.2 magnitude, and as recent as 2011 with a 6.4 magnitude. In 2004, a 6.6 magnitude level earthquake was again recorded on Vancouver Island. Now, a survivor of the earthquake, Bailey Martins, is here to give us the first-hand account. First of all, are you alright, Bailey? It appears you were injured. What happened?
Yeah, when I was in the earthquake, a lamp fell off a ledge and struck my leg, but appears to be healing fine now.
And what can you tell us about the earthquake? How did you respond?
When the earthquake first happened, I didn't know what was going on, but I tried to stay calm. When I realized it was an earthquake, I went under the desk in my office and put my hands over my neck and counted to 60 seconds twice, just like we learned when we were in elementary school. After that, I grabbed my emergency kit that consists of food and water, a first aid kit, a fire extinguisher, a flashlight, a portable radio, extra batteries, blankets, extra clothes and shoes, money, my medication, and a camp stove to cook on. I then went to check out the building to make sure it was secure, with no cracks or damages. I then checked my phone to make sure it was still working and put it aside to save it for emergency calls. I was just listening to my radio for information and instructions, but so far there hasn't been any. Then I came outside. I left a note on the door telling people that I had gone so they wouldn't be worried. Now I'm here with you.
That must have been terrifying.
Yes, it was. It was a powerful earthquake. It seemed like it was going on forever, but it must have only been a few minutes. Everything kept shaking and shaking. Windows were breaking, books and lamps were falling down. It felt like a huge vibration, and then there were a few aftershocks as well. So it was a good thing I followed the protocol and counted for 60 seconds twice. But when I finally had a chance to look around, there was also a lot of property damage. A lot of buildings were collapsed, as well as bridges and roads were useless. There were huge cracks running down them, and a lot of electricity poles and wires were laying about, as well as broken glass from windows and light poles. The damage was terrible. It is going to cost a lot of money to fix.
Thank you, Bailey. Now we go learn more about earthquakes and tectonic plates from seismologist Vanessa Kim. So can you tell us why this earthquake occurred?
Well, the boundaries between Earth's tectonic plates are the source of many earthquakes. They are caused by tectonic activity, which in other words means the movement of plates. Plate movement in turn can be caused by three things: mantle convection, ridge push, and slab pull.
And what plates were involved during this earthquake?
This earthquake was caused by the Honda Fuca plate descending beneath the North American plate along its subduction zone.
Interesting. You also mentioned tectonic activity. Care to elaborate?
Sure. First, in order to understand plate tectonics, it might be best to understand what the lithosphere is and the asthenosphere is. The lithosphere is a region formed by the crust and the rigid outer layer of the mantle, and the asthenosphere is the fluid-like layer of mantle beneath the lithosphere. The lithosphere is divided into 12 large sections or plates and 20 smaller plates. The tectonic plates float or are pushed and pulled over the denser fluid-like asthenosphere. As you now know, the movement of plates causes earthquakes. Each plate moves in a different direction. Some are moving away from each other, some moving towards, and some in a parallel motion. There are three different types of plate boundaries defined by their movement: convergent, divergent, and transform. Divergent boundaries are the point where the two boundaries move away from each other to create shallow valleys or rifts. And most rifts are under the ocean, at mid-ocean ridges, and cover the earth like seams on baseball. But when it cuts across land, it's called a rift valley. Small volcanoes and shallow earthquakes occur along these boundaries. Some examples are the Rio Grande Rift in New Mexico, the East African Rift in Kenya and Ethiopia, which occur on land. Under the ocean, there's the Mid-Atlantic Ridge and the Pacific Antarctic Ridge, as well as the Honda Fuca Ridge. Plates moving towards each other collide at a convergent boundary, and in some cases, the surface of one plate is scraped up, creating mountains, or, in another case, one plate is pushed beneath the others, creating a deep ocean trench at the boundary and a subduction zone where the two plates overlap. What happens at a convergent boundary depends on the type of plates involved. Oceanic convergent boundaries create islands such as the Philippines, or continental convergent boundaries create deep ocean trenches and parallel mountain chains such as that along the coast of BC. Continental convergent boundaries create inland mountain ranges such as the Himalayas. There's also the transform boundaries, which are when the plates move past each other in opposite directions. These are seen as strike-slip faults, where the land on either side of the fault line is moving in opposite directions parallel to the fault. Neither plate rides over the other, but the slip is not smooth and earthquakes are often resulting. The San Andreas Fault in California is an example.
Wow, that was informative. So the Juan de Fuca and the North American Plate are an example of a convergent boundary and the cause of the Vancouver earthquake? Now tell me, how are earthquakes measured?
Well, the magnitudes of earthquakes are measured on the Richter scale. The Richter magnitude is calculated from the amplitude of the largest seismic wave recorded for the earthquake, no matter what type of wave was the strongest. The Richter magnitudes are based on the logarithmic scale, such as base 10. What this means is that for each whole number you go up on the Richter scale, the amplitude of the ground motion recorded by a seismograph goes up 10 times. Using the scale, a magnitude 5 earthquake would result in 10 times the level of ground shaking as a magnitude 4 earthquake.
Wow, that was a powerful earthquake that hit Vancouver. Now, I've heard about the deep and shallow focus earthquakes, but I don't understand what that means.
Well, to clarify, the focus is the location of an earthquake's origin within the lithosphere. Earthquakes are categorized according to how far beneath the Earth's surface the focus occurs. Earthquakes with a shallow focus have a depth of focus of 0 to 70 kilometers, meaning it occurs within the region of the Earth's crust. A deep focus earthquake occurs within the region of the Earth's mantle and has a depth of focus of 300 to 700 kilometers. There's also the intermediate focus that has a depth of focus of 70 to 300 kilometers and occurs within the region of the Earth's subduction zone.
I have also heard there's different types of earthquake waves. Can you explain what they are?
Well, earthquakes transmit mechanical energy in the form of seismic waves, mechanical waves, or vibrations in Earth. There are two types of seismic waves, body waves and surface waves. Body waves travel through a medium, and earthquakes can cause two types of body waves, primary and secondary. Primary waves move parallel to the direction of travel and can travel through all types of layers of the Earth, such as solids, liquids, and gases. Secondary waves cause perpendicular motion and can only travel through solid rock and not through the Earth's liquid core. Secondary waves travel more slowly. Both primary and secondary waves vibrate through Earth from the earthquake's focus. Another type of seismic wave is the surface wave. They travel along the outside of Earth and are the most destructive, and are created when the body waves reach the surface. They travel more slowly than body waves, and the motion of surface waves decreases with the depth.
So then what is the epicenter of an earthquake and how can it be located?
Well, the epicenter is the spot at Earth's surface directly above an earthquake's focus. Devices called seismographs are used to detect earthquake waves. They measure the speed and direction of primary and secondary waves, which is used to locate the epicenter. With this data from seismograph stations around the globe, triangulation is then used to find the epicenter.
Well, thanks for coming down and letting us know about earthquakes. And to our viewers out there, remember to make sure you are prepared by having a meeting plan with your family in case you are separated. To prepare for an earthquake, you have to have a prepared standby kit that contains water, food, first aid, supplies, bandages, antibacterial rub, cotton balls, pain relievers, backup medicine if taken, etc. Clothing, an extra pair of shoes, bedding, and sanitation supplies. Portable radio, extra batteries, flashlight, and if you feel an earthquake, start at home and at school, go under the nearest table or anything that can provide protection for your body. With one hand, hold one leg of the table and with the other, protect your head and neck. Stay clear of windows, glass, or potentially dangerous surroundings. If there are no tables, go up against a wall and stay clear of lights, windows, electrical wires. Count 60 twice after the earthquake stops and make sure there are no aftershocks. And after an earthquake, check yourself and others for injuries, provide first aid if needed. Check water, gas, and electrical lines for damage. Stay out of damaged buildings. Check radio updates and follow emergency plans. Again, a big thanks to survivor Bailey Martins and seismologist Vanessa Kim for coming down to speak with you. And thank you for watching CBC News. I am Sam Guimian, and back to you, John.